Section 3.1. Is the area of figure A greater than, less than, or equal to the area of the shaded region in figure B? So by looking at this, it looks like I can cut this little part that's sticking out, this little square that's sticking out. Looks like I can decompose it. That means take it apart and then rearrange it and compose it back here in this empty space, which would fill up the gap. So that means these two shapes are pretty much equal in area. Section 3.2, on the grid. Each grid square is one square unit. Find the area in square units of each shaded region without counting every square. Okay, so just like the last lesson, I would probably decompose this shape into a couple of rectangles. You could do it this way, you could do it vertically or horizontally. So let's say I go horizontally. I can either count all the squares inside the rectangle to find the area, or I can do the long side, the length, times the short side, the width. I'm just going to count here. 2, 4, 6, 8, 10, 12. So there's 12 here. There's 3, 6, 9, 12 here. So I add these up, and my area is 24 square units. Over here, it looks like I have a gap. So maybe what I can do is find the area of this square. If this white gap was filled blue, and then I can take apart this gap and see what the shaded blue part is. So if I do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This is a 6 by 6 square. So 6 times 6 is 36. And then the little white square looks like it's a 3 by 3. So 3 times 3 is 9. So I can do 36 minus 9 and get 27. So 27 square units, because I'm counting squares, right? Okay, next problem is C. I've got a big gap right in the middle. Here I would probably use a different strategy. I'm going to decompose this shape and then rearrange this triangle. I'm just going to swing it down so it moves down here, and then it would fill up this space right there. So this will be gone. And then I can do the same thing. I can swing this triangle over, let it lay on its side. It would fit perfectly over this blue one. So then this would be gone. So now I've got all blue regions. So I can find the area of the rectangle separately. So it looks like the first one is a 2 by 4. 1, 2, 3, 4, 1, 2. So this would be 8. This is also 2, 4, 6, 8. 8 squares in here. So this looks like 8 plus 8 is 16. So 16 square units. Now the last one is a little bit more challenging. There's different ways to do it, but here's one strategy. Maybe you can create some triangles around the polygon here, so that it forms a big square, kind of like the one here in problem C. Now what I can do is pretend the whole thing is shaded. So this would be a 6 by 6 again, 2, 4, 6, a 6 by 6. I can do 6 times 6 is 36. But then I would subtract these white triangles away from it. So one thing I can do is probably swing over this white triangle over here. So it would kind of fit there. So this area would be 2, 4, 6, 8, just like problem C. And I can swing this one over, just like problem C. And it would fit right here. and the area would be 8. So that would be 16, right? So then I can subtract that from the entire giant square. I can say 36 minus 16, and then that way I can get 20 out of it. So 20 square units. Okay, the next section is 3.3. Find the area of the shaded region or regions of each figure. So here, what I would do is I would flip this triangle over to the top. Just flip it over to the top, so it's here. So now it looks like this piece is gone. It's up here, and it's a rectangle. So it's a 3 by 5. So length of 5, width of 3. I would multiply those and get 15 centimeters squared. So squared centimeter units. This one over here, just like the last problem, I can swing this one down here, or I'll do it like the last one. I'll swing it over this way, so it's right next to the blue one here. So now it's gone. So now it's a rectangle, 4 times 2. I would do 4 times 2, which is 8. So this area is 8 centimeters squared. I can bring this one over on its side. And now I have myself another rectangle at 2 by 4. So this would be 2 times 4 also, which would be 8 centimeters squared. And then I can add them up. 8 plus 8, which is 16. 16 centimeters squared. And finally, this looks like a big blue square, but we need to take out the white part because it's not shaded. So we can do a big area of this square. We could do 5 times 5 is 25. And then we could do the area of the little white square. We can do 2 times 2, which is 4. And then we can subtract 25, take away the 4, and we get 21 centimeters squared. All right, some strategies to find the area of the shaded region. You can decompose, rearrange, and compose again to make better shapes that you can find the areas of.